Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this video I will show you another component for our project. So this component that I'm going to show you is this vertical support here, which is a main component of our glass suction cup mount holder components, because this is a main component since it's a base support for the this suction cup mount holder. So basically we have here the suction cup, we have a slot here, we have a key here and put into the slot, as can be shown in this image. Let me check. Okay, this is our suction cup. We have a vertical key, then this our vertical support here will be mounted on the suction cup. So for this kind of component, which our vertical support here, for this kind of component, if we look at it, we have two parts. We have our bottom part, which a kind of dome shape, and we have a flat surface here, and we have another top part here. We have a vertical structure, a vertical column, a cylindrical column, and so in order for us to do this kind of component in SolidWorks, let me show you another view. So this is a closer view. We have at the top part we have a kind of rib here, we have a 4 rib there, and at the middle we have a slot. Okay, we have a slot. Then at this we have kind of a cutout here, a cutout from, actually this cutout here is where we mount our vertical casing that I've shown you in the previous video. So this our vertical casing will be mounted on this our base support here. Okay, so this how this both component is assembled. So our vertical casing here will be mounted on the base support, so it will form kind of cutout here. Okay, so in SolidWorks, so how we do it, I show you how I did it in SolidWorks. So this is a finished part. So let me drag this thing to the starting point. Okay, initially the first thing what I did is I made some revolve on the sketch plane. Is on the, if I zoom to isometric view, so this one will be, the sketch plane will be on the either right plane or front plane. Okay, so we have some sketch here. If I go to normal view, okay, we have some sketch here. So as long as we know the basic dome shape of this component, we know the cross section here. Since I already measured the cross section of this component, then we can do revolve along vertical axis to make the bottom part here. So these are the dimension. Okay, we have certain dimension. 35 is the, so we have 70 in total diameter, and 10 here. We have 11 here for the inner curve here. Then we have an offset of 2, and the flat surface here is 7.5. So then I can do revolve. Okay, I can do revolve on the vertical axis. Make sure I have a center line there. So we have our bottom part. So the next step is we do some boss extrude. Okay, the boss extrude here to make a vertical structure here. So basically in SolidWorks, it's a good practice we do it the main shape first, the main body first. Forget about all the detailing. There will be, we can do it later on. First we do the modeling of our main shape. We make the bottom part and our main shape of our vertical structure, which is a cylinder. The height of the cylinder from this base here is known. I already measured it, so I make some boss extrude where the sketch is about diameter 14. Okay, diameter 14, and the length of our extrusion is is 30 upward. So we have our basic cylindrical shape here. So the next step, we do some cut extrude from the top part here. Since in this image we have kind of inner cylinder here, smaller cylinder, then we make a cutout to form a shoulder here. Okay, so based on the sketch, diameter 9 from the top plane, so our sketch plane is on the top plane, then we use cut extrude with a certain length. The length of our cut extrude is 9 meter downward. Okay, so we make a cut extrude, so we will form the smaller cylinder here. Okay, so the next step, then I do some sketch here. In this case, this is not rib. What I did is I have a sketch. Okay, sketch on the top plane, make some sketch. If you look to the normal view, so we have some sketch here. Okay, we have some sketch. Actually, the sketch is we copied the edges by using convert to entities of these two inner circle and outer circle here. So what I did, I draw some line here. Okay, you draw some lines and do some offsetting and trimming. So then we do make a rectangular shape, then we do some trimming and deleting certain segment that we are that we don't want. So until we have our final profile here. So based on the sketch, I do some the boss extrude. The sketch plane is on the top surface. When we do cut extrude downward up to surface, so you don't have to use blind. So you just use up to surface instead of using blind up to surface. Then we select this surface, so the section here will be extrude to form kind of rib here. Okay, we have kind of rib. The next step is I make a tiny holes here with diameter 2. This hole is for a screw to be fitted into this hole to form in a thread. So later on we will do some subtraction from the screw. It will form in a thread. Okay, so the diameter is 2.1, and the extrude from this top surface, the plane is from that top surface, and the extrusion is through all. Okay, it's a through all, so it will form holes there. Okay, after we have a direct hole there, so I did some chamfer at these edges. Okay, at these edges I did some chamfer because we did some chamfering here. So the screw thread can easily fit it into here. So we have some chamfer here. So the chamfer distance is about 1 millimeter and 45 degrees. Okay, what's next is I do some cut extrude. If you look before cut extrude, we have solid cylinder. Then later, if the next step, what I did is I do another cut extrude to form a vertical slot. If you look, we have a vertical slot. Okay, we have a vertical slot as shown as in this image. So it's not quite clear here. Let me show the other image. So we have kind of slot here. Okay, this slot, actually the top part of the slot is curvature here. Later on I can do some filleting. Okay, so this slot is actually, if you look on this image, this is a bottom view of our vertical support. The slot actually is a cut extrude from this profile. The shape is a rectangular and another cross rectangular with each curvature edge. So from the sketch plane is from the bottom here, we can use, as long we know the dimension of this profile, we can use cut extrude from the bottom surface here to at certain height. Then okay, we know the cross section shape of here. From starting from this bottom surface, we made a cut extrude to a certain height, then you will find it will form a slot here. Okay, you form a slot there. So the sketch is with a certain dimension that I've already measured from the component. Okay, with the dimension of 16.8 here, and the sketch plane, is on this bottom surface. Okay, then we do some cut extrude with a distance of 30 mm. Okay, 30 mm and 30 mm. Since I already measured the slot height is 30 mm, then it will form a rectangular holes here. Okay, then I will do. Then what I did is I make a fillet at that corner. Okay, with radius. The radius of the fillet is 2 mm. Since our width is 4 mm, so it will form a semicircle. So we have these 4 edges here to form a fillet. Okay, then another cut extrude. Okay, if I go to isometric view, so we have another cut extrude for the circular slot. Before cut extrude, you have a solid dome shape here. Okay, we have a solid dome shape, and then after cut extrude, when we have a circular slot here. This circular slot, as shown in this image, we have a circular slot. Okay, circular slot. This circular slot is actually for this tightening. Our previous component, the tightener here, tightener will be mounted here. So we have the control, the handle here. You will be sliding along the length of this circular slot. Okay. So the cross section of the slot, same approach as before, and we have the profile of the cross section here. So we make a cut extrude from starting from the bottom plane here. Okay, if you look at the bottom, okay, if I go to normal view, okay, the sketch. So this is a sketch. I already measured the dimension with a diameter of 16 of the inner circle here. Then we have a offset of 3, and we have a semicircle here. Semicircle, actually the distance here is already measured by certain angular, but it's not shown in this sketch. I think you guys can know how to do this for basic sketching. So we have some angular here, and we do some trimming until we get this kind of sketch. Okay, so the sketch plane is from the bottom of this this bottom surface here. So we make a cut extrude, cut through. Okay, cut extrude through all, then will form a circular slot. So we have our circular slot here. Okay, the next thing to do is we have to, if you look on this image, we have a kind of slot here. Okay, so we need to put our vertical casing as shown here. We have vertical casing, it mount on the right position, so the actual position below this we have our circular slot at this area, and we have a cutout from this vertical casing here to be cut out to this component, our base support here. So what we need to do is we got to insert our component, we got to insert our part, this component. Okay, this component. Okay, our vertical casing here. So then after we insert it, so we make a move command. So make sure that our body to move is our vertical casing here. So instead of using translate, we use constraint. So mate setting here. So firstly, what we should do, we select some mate setting here. We select, for example, we select this face, this cylindrical surface here, and this surface here of this component. So automatically SolidWorks pull it into the concentric position. Okay, then I add to lock it. Then another setting is for the mate setting is we select the bottom surface of our casing and the bottom surface of our base support, and we lock it, right? We lock it. Let's click OK first. Okay, since it's already measured that the distance, the floor, I mean the bottom face, the distance where the casing will be mounted on the surface here, the distance from the bottom surface of this casing to the ground, to the bottom surface of this dome is about 9 mm. I already measured it, so in SolidWorks here. So we make a move in y-axis in the SolidWorks about 9 mm. So we insert another move command. So this casing is we need to move. So in our, we don't use mate setting now, we use translate. So we use translate. We have to move upward in y-axis, upward in y-axis about 9 mm. So make sure under translate setting, under y-axis we put it 9. We press enter. Okay, we press enter, so the casing will be moved upward in y-axis. Then we click OK. Okay, so make sure that the orientation of our cutting out version and the slot is in the same orientation there. Okay, and as can be shown in this image, circular slot is here, and our cutout surface will be in this curvature like this. So let's go to isometric view. Okay, since we have put our casing here, so the next thing I will do, the next thing that what I did is I put another component here. We have kind of gear here, cylindrical gear here will be fitted into this bore here, will be snap fit here, and we have a 4 slot here. And so the component of as can be shown this image. Let me show you if I have the exact picture of it. Let me check. So this is a component here. The component is here. So this kind of cylindrical gear will be fit into this the diameter of this component is fitted into this cutout extrude of this cylindrical shape here. Okay, so if I can show you this the component. Okay, this component we have if I show you the file, the name of the component is vertical bottom gear. Okay, so this kind of gear, okay, the bottom part of it, we have a 4 key here, cylindrical key. So this cylindrical key will be fitted into these 4 holes here. Okay, it will be snap fit here, and it will lock by these 4 holes. So the idea for us to fit to attach the cylindrical gear here, so that later on we can put our screw that we can cut out the screw to form inner thread for this bottom support component. So what we need to do is then we got to insert part of vertical bottom gear. Put it somewhere at the top. Okay, then what we need to do, same approach as before. We need to use insert features. We got to move it, the body to move with this component. So we use constraint, our mate setting. Firstly we select the cylindrical surface, and either edges, or let me clear this one. Let me do it again. Initially we are at this position, then we use features, move body to move with this component, and the constraint, our mate setting, we select the surface of the cylinder. If I zoom it closer and we select the surface, so automatically put it in concentric. If you zoom it, will be in a concentric version, in concentric position. Okay, we add it to lock edit to log. So the next move is that we got to, since if we look, this component happen to be the holes and the key, the cylindrical, the four cylindrical and the hole is actually in the right orientation. So our next mate setting, we should select the surface, we should select the next setting, we select the bottom surface here of this component and the top surface here. So it will snap fit into the holes there, okay, into this casing. So our gear component here is in exact position. So then we lock it, then we click OK, then we go to isometric view. So the next thing to do is we got to insert our screw component. We insert part. So the name of the screw is let me check, screw, not screw for mounting plate, screw for vertical support. So now we have our screw here. Okay, let me zoom out a little bit, and I put it somewhere at the top. Okay, use same method. You got to rotate it by using move copy. Body to move is the screw. The first thing what we should do is we use rotate it on the Z axis 180 degrees. Let me try. Okay, let me try on not Z axis. Sorry, this is translate. This is a translate. We don't use translate. We use rotate at Z 180. So we have in the right orientation. So click OK. So our screw in the right direction. Okay, then we use again features. We got to move again. So select the screw. Our body to move is the screw. Then instead of using translate or to rotate, we use constraint. We carefully select the cylindrical surface here and this cylindrical surface, so that is position on concentric. So the position will be concentric. Then we lock it, click add, we lock it, then our next setting for mate, okay, our next setting is to select this surface, the bottom surface of our screw head, and this surface. Then we click add, then we click OK. So our screw is locked to this position. Okay, so our screw is locked into this position, so then we can do we will do subtraction. Okay, we go to isometric view. Okay, then we go to insert features. We use instead not move copy, we use combine. Our main body is since this our vertical base support here is our main body, and the bodies to combine is the screw. Since we want the screw to form in a thread to this base support, so we select the screw, select the screw. Okay, then make sure the setting operation type here is subtract, then we click OK. So our base support here will be subtracted. The pin will be subtracted from this base support to form the inner thread. So we need to, the next thing what we should do before okay, the later on, since we have in this image, as shown in this image, we have a cutout. I haven't subtract yet the casing from this base support, so we use the same approach. Okay, so we use the same approach. We go insert features, combine. Our main body is our base support, and bodies to combine is our casing here. Casing, operation type is subtract, then you click OK. Right, so then we have a cutout portion of this base component. Okay, so this gear component here is not part of this this base support component, so we need to hide it. So what we need to do, we select the gear component, then we go, you click at hide. So then we have our finished part. Alhamdulillah, so we have done the component. So this I hope this video will show you, will guide you, and you can use this video as a reference for you to do your part modeling. Okay, Alhamdulillah. So thank you very much again for watching this video. So I'll be seeing you on the next video session. Assalamualaikum warahmatullahi ta'ala